Hello everyone, this is Duan, and this week we're going to look at three of the most confusing CSS properties that are used in a Flex layout. So those properties are the Flex Grow, Flex Shrink, and Flex Basis. Most people are confused about how those properties behaves because those properties are different from a lot of the other CSS properties, which are fixed, like width or height, font size, colors, so on. But those properties actually behaves quite differently in response to different siblings or different sibling properties. So in this video, we're going to a deeper look at each of those properties so you can have a better understanding of how the flex item properties behaves in your browser. Let's get started. All right, so this is a little example I've set up in the CodePen. And as you can see, this is just a Flex container with 500 pixel width, and it contains three Flex item inside of it. We're going to use this little example to demonstrate the behaviors of those Flex properties. Before that, there are two very important concepts we need to understand in order to understand those behaviors. The first concept is the idea of sizing. The Flexbox will first look at the size of the flex item in order to decide on how it's going to be expanded or shrink down. In this little example, as you can see, the browser will know each of those flex item has 100 pixels as a width because I've specified a width of 100 pixel. But what if I don't specify this dimension here? As you can see, the flex item is being shrunk down to just enough width to display the content. So this is the idea of max content. So whenever you don't specify the dimension of the flex item, the container will always use the max content to calculate the dimension of your flex item. So if I were to add a width of max content, you'll see that nothing has been changed because this is what the browser is using. So you may wonder something that's a little similar, but it's also different. It's called the main content. So this is the main content. So if I were to change it to main content, nothing has changed. So you may be wondering what's the difference between main content and the max content. So there is a difference. Let's demonstrate that. Okay, so let's change this back to max content. And I'm going to add some characters to the last item inside of my flex container. So that will be the third item. So I'm just going to type some gibberish here. And yeah. So as you can see, in the max content, all of the characters I've just typed is being displayed, but they're because it's actually bigger than the container, it overflows the container. So the max content, what essentially it does is it will show all the content. If the content size is bigger than the container, it will overflow it. But everything is displayed on one line. So if I were to change this to main content, change it to main content, as you can see, the content is being wrapped. So you can still see all of the content on the screen, but some of the content, some of the characters I've typed is being wrapped into a new line. So by definition, what the main content does is that it shows all of your content, but also taking all of the opportunity to do softer wrapping if possible. And the next concept we want to understand is the idea of available space. So in this container of 500 pixels, we have three items with width of 100 pixel, and we're left with 200 pixel, which is showing in the pink color here. So this 200 pixel space is what we call the positive available space. And this is very important when we're going to talk about the Flex Grow. The Flex Grow uses the positive available space to expand those items. And the other thing is what we call the negative. So if I were to change the width of the flex item to 200 pixels, as you can see, the third item has overflowed the container by 100 pixel. And this 100 pixels is what we call the negative available space. And this is also very important because the flex shrink will use the negative available space to calculate how much the item needs to shrink down. Okay, so with those two concepts understood, and let's move on to each of those properties. The first property we're going to look at is the flex basis. So typically we combine the value of flex grow, flex shrink, and flex basis in one line. I have isolated the flex basis because the flex grow and flex shrink are zero, basically means they're not taking any effect at the moment. So we're only looking at the flex basis. What the flex basis is that it's the width or it's the dimension of the flex item before the amount of available space is being calculated. So for example, if I have set this to 100 pixel, so let's so let's remove the width here, and let's put this to 100 pixel. So the flex item will have a width of 100 pixels, and the available space will be calculated based on this. So in this example, we're going to have a 200 pixel of positive available space, and that's all what it means. So if I have set this to 200 pixel, then I have a 100 pixel of negative available space. But often than not, you will see something like auto. So what the auto does is that the browser will look at the styles for this element. If it does have a absolute value, absolute dimension to it, it will use the absolute dimension. So things like width, we have specified before. If I specify that, the flex item will use this dimension. But if I were to remove it, it will use the max content as we have mentioned. So the max content in this case will just be the minimum amount of space to display the content. So with that cleared, that's all what the flex basis does. The next flex property we're going to look at is the flex grow. And the flex grow is the first value inside of the flex property. So you can specify it here. So essentially what flex grow is, the value of flex grow is a relative proportion value that is used to divide up the positive free available space and given to this flex item. So what I mean by that, for example, if I were to change this value from 0 to 1, and you can see the container no longer have the positive free available space, is because they are divided into 3 portions. So each of the flex item has a flex grow ratio of 1. So they adds up to 3. So the space is being divided by 3, and each portion is given to each of the flex item. That's why you can see all the items are still having the same size as each other because they are all giving the same amount of free available space to them. And this value is because it's a ratio, you can change it however you like. For example, if you change it to 4, change it to 100, it's the same because the ratio is still 1. But you can change the proportion individually. Okay, so now I have added the flex grow property to each items individually. They're all 1. That means the available space is being divided and distributed evenly. If I were to change the middle item to 2, as you can see, the 2 is slightly bigger than 1 and 3. This is because the positive available spaces is being divided to 4 portions, and 1 portion is distributed to 1 and 3, and 2 portion is distributed to 2. So if I were to change this one to 2, and then the 2 and 3, it will look about the same size, but 1 will be smaller. It's because those 2 have same ratios, whereas the 1 only gets half of the space as the other ones. The next property we're going to look at is the flex shrink property. The flex shrink property works kind of oppositely to the flex grow property. So instead of working with the positive available space, the flex shrink works with negative available space. So in this example, we don't have any negative available space. So the flex shrink should not work. We can demonstrate this by showing, okay, so let's have a flex grow of 0, so it doesn't grow anywhere. And flex shrink is 1, and the basis will use the auto. As you can see, it doesn't actually change anything. So if I were to change this to 2, changes this to 3, changes this to 0, nothing changes because we don't have negative available space to work with. So nothing needs to change, even the flex shrink changes. When the flex grow takes effect is when your element actually creates the negative space. So let's make this 0 again. So let's increase the width of each element to 200 pixels. We created a 100 pixel negative available space. And now if we make flex grow value to 1, as you can see, the elements are shrink down to the container width of the container. It doesn't overflow anymore because the negative available space is divided using the flex shrink values as proportions and taking some space away from each of the flex item. So because we specify the ratio to be 1, each flex item will have the same ratio, and which is the reason why same amount of negative space is being taken away from each flex item. That's why they still look the same size as each other. Let's give another example. So if we have flex shrink individually, it's the same as before. They will be all taking same amount of space away from them. So if I were to change this one to 0, so if the middle one doesn't have any ratio to them, that means the negative space will only be taken away from the first flex item and the third one, but not the second one. The second one will still have the same amount of space, which is the 200 pixels. So we can confirm that if we open the DevTools. So let's look at, so this item has 200 pixels and the other ones have 150. And remember, we have 100 negative space, and this item initially has 200 pixels, is taken away 50 pixels. Okay. Okay, so it's very similar to flex grow in terms of how it works when dividing up the available spaces. It's dividing the negative space instead of the positive space, but there's actually another huge difference as well. It's actually taking consideration of the size of the elements as well. So because we have the same initial size, we couldn't tell the difference. So let's make it different for each item. Okay, so let's make all of the flex shrink to value to 0 as a start. And I'll make the first one has a width of 50 pixels. Okay, 50 pixels is quite small, but the second one has a 50 pixel as well. And the third one, instead of 50 pixels, I will give it 500 pixels. So now we still have that 100 negative space, as we can see here. So in this case, if we were to specify flex shrink value of 1 on each item, what will happen is that we have 100 negative available space. So each item should be taken away about around 33 pixels, right? But in actuality, it doesn't work that way. So if we inspect those elements, we can see that the red and green has a width about 41 pixels, 41, 42 pixels, and the initial width is 50 pixels. So it's actually taking away 8 pixels approximately. But the third one has initial width of 500 pixels, and now it has 417 pixels. So it's taken away about 83 pixels. So the other one's taking about 8 pixels, and this one's 83 pixels. And why is that? Because the flex shrink, in addition to the ratios, it also taking consideration to the size of the element as well. As you can see, the third element has a size of 500 pixel, which is 10 times bigger than the other ones. The actual ratio of the negative space that is taken away from each item is 1 to 1 to 10. In addition to the flex shrink ratio we specified here, it also multiplies by the size ratio between the flex items. So the bigger item will be taken away much more negative space than a smaller flex item. As you may have noticed previously when I was demonstrating this example for flex shrink, there are moments when I was changing the flex shrink value where the third one is 0. Okay, so in this case, we do have the negative space of 100 pixels and it's being taken away partially from the first one and the second one because the third element or the third flex item has a flex shrink value of 0. The third item actually doesn't shrink down at all. So what happens is that all of the negative space are taken away from the first and second one. As you probably can imagine, because the first and second one has a width of 500 pixels, and the negative space is about 100 pixel. So if it were to be taken away by the first one and the second one, that means 1 and 2 should disappear, right? But no, it doesn't disappear. It still appear here, and the negative space is still here. So if we inspect using the dev tool, you can see that the 2 is about 26 pixels, 27 pixels. 1 is the same, 27 pixels. And it's taken away about 23 or 24 pixel from the negative space. And the third one is still 500 pixel. That doesn't change because we didn't tell it to shrink. So why is first and second one still on the screen? Because the flex shrink actually has a limit. So that limit is min content. So we've mentioned the max content and the min content. If you remember correctly, min content is the dimension that displays all the content on the screen while takes all the opportunity to soft wrapping the content. So in this case, in order to display the content, all of the content in the screen, the flex item has to have a minimum of 26.7 pixels to display the numbers here. So the 1 and the 2. And this is the reason why it doesn't shrink any longer. So if we were to remove the numbers, remove the 2, for example, and now it's gone because it doesn't need any space to show the content. And now we have the element being completely shrink down to 0. On the last note, I would like to quickly discuss what we've discussed about the flex item properties we've mentioned. So the flex properties such as flex grow, flex shrink, and flex spaces, They uses three things to decide their behaviors. One is the size of the container. They use the size of the container, and the second one is the size of the flex item, and they uses that to determine the available space, whether that's positive or negative. And once it's determined, it uses that to determine how it's going to be expanded using flex grow or shrink down using the flex shrink. Okay, so that's everything you need to know about the three most confusing properties for flex items. I hope you enjoyed the video. If you like this video and would like to see more related content, please consider like and subscribe. If you have any questions you'd like to ask, just leave a comment below and I will answer it when I can. I hope to see you in the next video. Bye bye.